Okay, good morning. Welcome to
FunMath number 44.
FunMath number 44. Today we're starting a new chapter in our Art of Problem Solving book, and it's about bases. Now, we've talked about bases before, right?
Yeah.
And it starts with just the regular numbers that we usually talk about, like 743, which is in base 10. But we don't usually write the base 10 because that's what we're almost always talking about.
Yeah.
Right? But what does 743 mean?
It means 7 hundreds.
It means 700
plus 4 tens.
plus 40
plus 3.
plus 3. Or 7 times 10 squared plus 4 times 10 to the 1 plus 3 times 10 to the 0. 10 to the 0? What does that mean?
It's 1.
10 to the 0 is 1. In fact, anything to the 0 is
1.
1. Okay? So this is what we call base 10, or do you know what the other name for base 10 is?
Decimal.
Decimal. And do you know what deci means?
10.
In what
10.
language?
Deci in Latin.
Is it Latin? I'm not sure actually. It might be Greek.
Yeah, I don't know.
Okay, one of those two. I think it's Latin, because deca. Decagon, maybe that's Greek. Deca, deci. Sorry, I shouldn't have brought it up because I don't know for sure. But in any case, is there anything special about 10?
Well,
Did our number system have to be 10?
no.
Do you know why it's sometimes a little convenient to use tens?
They're easy to count by.
Well, they're easy to count by, but we have 10 fingers, so that makes it a little bit easy, right?
Yeah.
In fact, I know it's a really special way to count up to 20. Do you know how? I just take off my shoes, use my toes. Okay, but there's nothing special about 10. So we could also talk about the number 743 in base 8. And that would mean 7 times 8 squared plus 4 times 8 to the 1 plus 3 times 8 to the 0. Okay? Now what is 8 squared?
8 squared is 64.
64. So if we were going to convert this back to base 10, we would say this is the same as 7 times 64 plus 4 times what's 8 to the 1?
8.
Plus 3 times what's 8 to the 0?
1.
1. 3 times 1. Okay, 7 times 64 is?
It's 420. 7 times 60 is 420, plus 7 times 4 is 28, so it's 448.
448 plus 4 times 8 is?
32.
32 plus 3. Okay, what's 448 plus 32?
It's 480.
480. 480 plus 3 is?
483.
483. Okay? So in base 10, 483 is the same as the number 483 is the same as the number 743 in base 8. Okay? Those are the same number. They mean the same thing. Now, what's a very common base that people use that's different than base 10?
Base 2.
Base 2. And what's that called?
Binary.
Binary. The neat thing about binary is it's only ones and zeros. 1, 0, 1, 1, 0, 1. Base 2 means this is the 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, and 2 to the 5th. So the number 1, 0, 1, 1, 0, 1 base 2 means 1 times 2 to the 5th plus 0 times 2 to the 4th plus 1 times 2 cubed plus 1 times 2 squared plus 0 times 2 to the 1 plus 1 times 2 to the 0. Okay, what's 2 to the 5th?
32.
32 plus 0 plus what's 2 cubed?
2 cubed is 8.
8 plus 2 squared?
4.
Plus 0 plus 2 to the 0 is?
1.
1. Okay, so this crazy number, 1, 0, 1, 1, 0, 1, base 2 is the same as 32 plus 8 plus 4 plus 1, which is?
Is 45.
45. In base 10. Okay? Why is binary so popular and so important to learn?
It's what computers.
That's what computers do. That's how computers count. They count in binary. Okay.
Sometimes in hexadecimal.
Yeah, sometimes. Okay, but this is all different bases, and the neat thing about bases is there's nothing special about base 10. We get really used to counting in base 10, but as we learn more about bases, you'll see that all other bases are really pretty much the same.
Yeah.
So in base 10, multiplying by 10 is really easy, right? Because you just add a 0. Right? In base 2, multiplying by 2 is easy because you just add a
0.
So there you go. All right, high five. Good job today learning about bases.